All right, let's talk about an invisible force that honestly shapes just about everything around us, from the tiniest little things to, well, the truly spectacular. You've definitely felt it before. I mean, what else is the reason for...
You know that sound? Right? That little crackle when you pull a sweater over your head in the dark. It's like your own personal tiny light show, complete with sound effects. Yep, that's it.
Okay, now take that tiny little spark and scale it up. I mean, way up. Because believe it or not, the exact same fundamental force is behind the raw, incredible power of a lightning strike ripping across the sky.
Or, hey, what about this one? You slide across the seat in your car, you go to touch the metal door handle, and zap, you get that little shock. All of these things, from the sweater to the lightning to the car door, they are all connected.
So what is this invisible force? How can it be gentle enough to make your hair stand on end, but also powerful enough to light up an entire sky? Well, that's what we're here to figure out. Let's dive in.
Okay, the culprit, the answer to all of this is something totally fundamental to matter itself. It's called electric charge, and as scientists figured out a long time ago, it comes in two, let's call them flavors.
So electric charge, it's just a basic property of matter, kind of like mass. It's just there. And the way we first figured this out was pretty simple, really. Early experimenters noticed that when you rub certain things together, they'd suddenly start to push or pull on each other. And pretty quickly they realized, we're not just dealing with one kind of this charge, there are two. And their method was so simple, it was brilliant. For instance, you take a glass rod and rub it with a piece of silk. What happens? The rod picks up one kind of charge, and the silk cloth picks up the other kind. And the guy who finally gave them the names we still use today, none other than Benjamin Franklin. He's the one who called them positive and negative. Okay, so we've got our two players, positive and negative charges. The big question is, what happens when they get near each other? How do they interact? Well, it turns out the rules are super simple, but they are also incredibly powerful.
All right, rule number one is easy. Like charges repel. That means if you bring two positive charges close, they're going to push each other apart. Same deal with two negative charges. It's like they're saying, nope, get away from me.
And rule number two, you guessed it, it's the classic opposites attract. Unlike charges pull towards each other. A positive and a negative charge, well, they can't get enough of each other. That's the whole dance right there.
So that's really the foundation of the whole thing. Two kinds of charge, positive and negative. Likes repel, unlikes attract. Simple. But that brings up a really important question. How strong is that push or pull? I mean, is it a little nudge or is it a huge shove?
Well, for that answer, we've got to talk about a French physicist named Charles Coulomb. See, he was the kind of guy who wasn't happy just knowing that charges push or pull on each other. He wanted to know how much. He wanted to put a number on it, to actually measure the force.
And what he discovered is absolutely key. Basically, the force between two charges depends on two things. First, the amount of charge. The bigger the charges, the stronger the force. And second, the distance. The force gets weaker the farther apart they are. But it's not just a little weaker, it gets weaker by the square of the distance. So if you double the distance, the force drops to a quarter of what it was.
And this all gets wrapped up neatly in this beautiful little equation. This is Coulomb's law. It basically says the force, F, is equal to some constant, K, times the two charges, Q1 and Q2, divided by the square of the distance, R, between them. This one formula lets us calculate that push or pull precisely, every single time.
Okay, so we know how to calculate the force, but just how powerful is it, really? To give you an idea, I want you to look at this number, 10 to the power of 39. That is a 1 followed by 39 zeros. It's a number so big our brains can't even really comprehend it.
So what does that ridiculous number actually mean? Well, get this. The electric force between a single proton and a single electron is 10 to the 39th times stronger than the force of gravity between them. It's not even a contest. On the scale of atoms, the electric force absolutely dominates. Gravity might as well not even be there.
But that leads to a really deep and kind of weird question, right? How do two charges know the other one is there? Especially across empty space. How does that force travel across nothing? How do they feel each other?
The answer to that question was a total game changer in physics. It's a revolutionary idea called the electric field.
Here's the mind-bending part. A charge doesn't actually reach out and pull on another charge directly. Instead, it changes the space around it. It creates this invisible web of influence, this electric field.
Then, if another charge wanders into that field, it's the field at that spot that pushes or pulls on it. It's not action at a distance, it's a local interaction with the field. And we have these great ways to visualize these fields, using what we call field lines. And there's a simple rule. For a positive charge, the lines always point outward, radiating away from it. And for a negative charge, you can see the lines all point inward, pulling towards it.
Now this is where it gets really cool. When you put two opposite charges together, their fields combine. Look at this. You can see the lines flowing from the positive charge and curving right into the negative one. These lines literally map out the path of attraction between them.
But check out what happens when you put two like charges together, two positive ones in this case. The field lines push away from each other. They curve and bend, trying to get away, creating this empty space right in the middle. You can literally see the repulsion in the shape of the field.
You know, this idea of a field isn't just some abstract physics concept. It is an absolute cornerstone of all of modern physics. It's the reason our phones work, why the lights are on. It's fundamental to pretty much all the technology we rely on every single day.
So we've explored this incredible invisible landscape of force that's all around us. And it kind of makes you wonder, doesn't it? If a force this powerful operates through an unseen field that literally defines our reality, what other invisible landscapes are still out there, just waiting to be mapped?